All right. Good evening. If we can come on over. I know I don't mean to interrupt all the fun connections being made tonight, but I promise we'll leave some time at the end for that. So why don't we all squeeze on in? All right, well, thank you all so much for being here. So excited to have you all tonight for our Austin Fast Start Cleantech pitch competition. My name is Joanna. I am the president and CEO of the Austin Young Chamber, and we are dedicated to developing young professionals here in Central Texas. So we work with the business community and community partners to provide resources and opportunities to develop young professionals, including pitch events just like this. So tonight's Austin Fast Start event is basically a reoccurring pitch competition designed to support Austin.
Swap one for the other.
There we go. Yeah, an early stage pitch competition to support early stage entrepreneurs and startups. And this is a partnership between the City of Austin's Economic Development Small Business Program. And with that, I am very happy to bring up Jackie Mayo, who's the class and events coordinator with the Small Business Program with the City of Austin. And she's going to go over a little bit about what they do.
Joanna. Good evening, everyone. Before I get started, congratulations to our finalists on getting thus far. I'm super stoked to learn about what Cleantech is. I'm not gonna lie, I don't know what it is. So I want you guys to tell me what it is. As Joanna said, I am with the Economic Development Department, the Small Business Division, and we basically are the training arm for our Economic Development Department. We provide small business training for our entrepreneurs. Your success is our success, is Austin's success. So we want to equip you with all the tools and resources that you need to be a better small business owner, a better entrepreneur, and we offer, I think we have about 41 different classes currently. Everything from basic bookkeeping, boo, but you need it. Social media, yay, building your content calendar, as well as building a business plan. Yes, a business plan. You guys need a business plan. We have a myriad of them. Go to our website at smallbizaustin.org, click on classes, and you'll see a whole slew of classes that are for nonprofits, the creative community, as well as your traditional small business. As I said, we want to make sure that you guys are successful. We don't want you flying out there on a limb. We want to make sure that you have everything that you need so that in 5 years you can come back and say, Jackie Mayo, I'm a success. Also, I want you to mark your calendars for me. Friday, October 21st, from 11:30 to 1:30 is our annual Women's Entrepreneurial Luncheon at the Hyatt Regency downtown. It's a plated lunch. Our featured guest speaker is, some of you may know her, Natalie Madeira Cofield. She used to be the president CEO of the Austin Black Chamber, and now she's with the Small Business Administration's Women Entrepreneurial Division section in DC. So she's our featured speaker. Our moderator for that day is also going to be, she's formerly with the Austin Chamber, Lee Christie. And then we have Jessica Chin with the Asian Chamber of Commerce, as well as, and I kill her last name every time, Monica Sinceros.
She's here. I'm gonna call her out.
Where is she? Sinceros, I need to talk to you. With the cathedral. She is on our panel as well. So I hope to see you guys there. It's gonna be a great time. It's just a great opportunity for everyone to sit and mingle and eat and network. Yes, sir?
You said women's. Is it open to men and women?
I guess. Yes, it is. It is. You're more than welcome to come. So I hope to see you there. Visit our website. You can go and register there. So good luck to everybody today, and let's have some fun.
Woohoo, thank you. Yeah, Jackie's the best, and that whole team is as well. Yeah, and if you can see here on the slide, please get involved, especially if you're a small business owner. This is definitely the resource you need. As you all can tell, we are inside of Capital Factory, and we also have a judge here who is actually the executive director of 3-Day Startup, and we could not have done this without their support, so let's give them a round of applause as well. All right, and then just another little plug here. If you're taking pictures tonight, which I hope you do, and you feel inclined to share them on social media, please, please, please tag this hashtag, Austin Fast Start. And are we also doing the Cleantech hashtag? No? Okay. Just the Austin Fast Start a hashtag, and those are our channels. You should be following us anyway, so if you haven't already, please do so now. All right, so how do we get here? We are going to be seeing the finalists tonight, but how do we get to this process, get to this point of selecting the finalists? Well, since January, we accepted applications from local clean tech startups and small businesses to pitch on stage. We look for businesses with sustainability in mind. So that could look like recycling, renewable energy, information technology, green transportation, electric motors, green chemistry, you get the picture. And applications were reviewed by our judges. And so before we get to our finalists, I do want to take a moment to introduce our judges here who have just given up their precious time to be here with us. So Corey Delina is Vice President and SBA banker with Regions Bank. Erica Haskins, Chief Executive Officer, sorry, I said Executive Director, with 3-Day Startup. And then Donetta Smith, Director of Education with People Fund. And Ezine Udezue. Yes, nailed it. Okay, Chief Product Officer at WP Engine. Thank you so much. Can we get another applause for them? Okay, so in terms of how we're actually selecting the winner tonight, so we are going to be combining a score with the judges' scoring, which is 80% of the total tally, and then an audience score. So yes, you people in the audience have, you can choose their destiny tonight, basically. I know, no pressure, right? So after finalists have pitched, so judges, you will have an opportunity to score at the end of each pitch. And Aubrey here, our business development associate with the Young Chamber, will be collecting your scores after each pitch. But the audience, you just have to sit there pretty and watch and absorb. And at the very end, we're gonna put up a slide with a QR code, and that's gonna give you all the instructions you need to vote for basically your favorite pitch. And what's the prize? All right, so we have a prize of a $2,500 cash prize. And in addition, they're also going to be receiving 3 months free rent here at Capital Factory. And then, yeah, I know, wow. And then our friends, VCFO, are also offering a 1 hour, 2 hours of financial and HR consultation. And then, not to brag, but I think one of the coolest prize options is a 1-year corporate membership with yours truly, the Austin Young Chamber. Okay, and then I'm going to call up each competitor, and they're going to have 5 minutes to pitch, and then they're going to have 8 minutes with the judges. If the judges don't end up using all of their 8 minutes, we will give the audience a chance to ask some questions. All right, are we ready? Yeah? All right. All right, so I would love to bring up to the stage our first finalist, Tubular Network, pitched by Ben James, co-founder and CEO.
Testing. Fantastic. My name's Ben. This is Tubular Network. Our mission is to decarbonize the transportation of goods. And Jackie, to your question, what does clean mean to me? It's decarbonizing transportation. So imagine a world in which you order something and minutes later, it's in your home. This is what we're building at Tubular Network, and this is how it looks. At a warehouse, we're able to load boxes onto the Tubular Network, where these robotic delivery shuttles do nonstop 60-mile-an-hour journeys throughout the city, straight to your house, your apartment, your place of work. And they can go underground, up many floors, deliver straight into an apartment lobby, for instance, where there's a kind of protection from consumers so that the package is only presented when it's ready, and sending things back into the network for returns or to send sugar over to your grandma across town is just as simple. So we're creating the next great utility, which is the movement of goods, at least 10 times faster and with 0 carbon emissions. So it's a really important mission because of all the things in the United States that cause carbon emissions, transportation accounts for 27% of it. So we feel like we're going straight for the jugular and fighting for climate change. Now, I say citywide infrastructure, we're getting started in manufacturing. So in industrial parks where there's a large volume moving over a very short distance. This is great because we have to build a small tube that gets to go to work a lot more. Similarly, in terms of sustainability, manufacturing is creating millions of pounds of emissions on campuses like this. And if products don't get in on time, production lines go down. And companies like Toyota or SpaceX know exactly how many hundreds of thousands of dollars a minute they're losing by having that production line down. Add in the labor supply shortage right now, and it's the perfect time to automate this kind of job. So the main value proposition, for every truck we take off the road, we are reducing 223 million pounds of carbon emissions a year. So if you've got an operation like that where they've got 100 trucks, just multiply that number by 100 and go hug a tree. It's fantastic. And in terms of the logistics, it's just as disruptive because today they have to load up a truck for an hour and a half to drive it across a parking lot and then unload it for an hour and a half. We can get the transit time down to 3 minutes. How does a customer get a Tubular Network? Well, I told you we're targeting manufacturing campuses, but really anybody moving a high volume over a short distance is what we're looking for. We outsource most of the complexity of the construction to a civil engineering utility construction company. So the same ones who do the storm drains down your street, down every street in Austin, are the same ones building Tubular Network, the biggest part of it. And we drop in our robotic shuttles and we're operational. And the end result, 0 carbon emissions, 60 times faster delivery, 10% operational expense savings, which is huge in logistics, 30 headcount to reallocate and put on more meaningful parts of the process. And as far as the business goes, a 70% margin over 5 years for us. Who's making this? This is my background. I've built the future of sustainable transportation a few times now. Once building a maglev train, actually 3 times building Hyperloop pods for the SpaceX competition with the University of Texas at Austin and MIT. We actually revealed our first pod right over there. So this is a very special space to me. And then I came up with the idea of Tubular Network. And I've got the most incredible team helping me build it. So Dylan is the engineering lead. He's one of those 10X engineers who's insanely talented. Professor Zhao is a professor at the University of Texas at Austin, teaches on sustainability, smart cities, and logistics. Right now, we're building a full-scale prototype at the Austin airport. This is our 112th prototype. I'll show you that in just a second. And the second phase, we're building a pilot for SpaceX. So they've already signed on as our pilot customer, and we're going to be moving rocket parts within the year. And this is what it looks like at the Austin airport. This is 4 months ago. So in this video, you can see a full-size package. This is a 2-foot-long package, up to 30 pounds, that we can already automate pickup, transit down a tube, and drop off. If we win, I'll be moving my office down here to Capital Factory. I'm really looking forward to networking from the Austin Young Chamber, the advice from VCFO, and of course the money is going to go towards R&D. thank you and help join our mission to decarbonize the transportation of goods.
Woohoo! Thank you, Ben. Can you hear me? Yeah, you can. All right, judges, you have 8 minutes.
Hey, Ben, how are you?
Doing great.
Awesome. Very nice pitch. Just a couple random questions around infrastructure. So this goes underground mostly, but can go above ground as well.
Correct.
All right. When it's underground, I guess my first question would be like city permitting, those types of things. That's all done via the group that you had discussed, or how do you get the city involved with that?
That's a great question, and one that we want to work with the city of Austin on. It is going to follow the same engineering and permitting as storm drainage tubes today, and we have a competitor also out of Capital Factory that already got one permitted in Georgia. So you just apply for a permit for a water drainage system, and it's gotten approved at least once.
And then I guess my next question would be around what if you get a broken or clogged tube that's underground?
Great question. These are dedicated tubes just for tubular network and the transportation of goods. They're track systems, and so far we've had 0 dropped goods over hundreds of deliveries. In the case that it is dropped, we're developing a robotic recovery shuttle. So imagine that same shuttle with 2 robotic arms and then a camera so that a remote operator can pick up any issue. And then in worst case scenario, these follow the same access points as like storm drainage. So every 300 feet, there'll be a manhole with an access point. And in any given city, there are folks trained for closed space. So worst case scenario, we can send in a human to recover it. The failure modes most likely are not going to be inside the tube, but at the ends. Great question. Yeah.
Hold on. Yeah, I want to follow up just to make sure we understand. So your intellectual property, or what it is you're focused on, is on the robotic shuttles and the track system?
Correct.
Okay. And then these will be parallel to storm drains, that they will work alongside and be fully dedicated?
Separate,
Okay,
yes.
good. So a couple questions then. Have you thought through, or do you have an estimate of the impact that these construction companies that you will employ to build the tracks will have themselves? Do you understand that question?
Like the carbon emissions of construction.
Exactly, of
Yes.
constructing those things. The second part is, who are you selling to? So in the manufacturing plant, who is your buyer?
Sure.
Who are you, who's your buyer? Let's start there.
That's a great question. So first question, the carbon emissions related to construction is not a known quantity to us yet. We're still wrapping around a model of how much we're offsetting carbon emissions of transportation. So Professor Zhao is putting together that model. And as we work on our first system going in place with SpaceX and beyond, we'll be looking at the construction carbon emissions related to it. So I don't know, but it's something that we deeply care about, because when you're looking at sustainability projects, you have to look at the full life cycle. Secondly, who's buying it? The beauty of working with manufacturing is it's typically one stakeholder. The person who owns the property, owns the buildings, and is in charge of logistics in between them. So in this case, SpaceX is our pilot customer. In the future, we'll be looking at more manufacturing customers, so single stakeholder buyers. Eventually, we want to become similar to fiber internet, a utility in a city. So in that case, we'll work with the city to implement it, and then the buyers will be individual businesses and residents.
Well, in that case, so when I say who's buying, so at Tesla, did you say Tesla? Or
SpaceX.
SpaceX, who did you convince to sign up for
Sure.
this particular, which individual or which role?
This particular one is in charge of the supply chain. So the manager of their supply chain team, they have dozens of employees that move things around the campus today.
Thank you.
Yeah, great questions.
I have 2 questions. One, you said the largest package is 30 pounds?
For this, yep.
Oh, it's not happy.
No. Okay, thank you. 30, you said 30 pounds, right, is the largest package. So my question is, if you have someone, first of all, who needs a larger package or who needs more, how do you handle that? So let's say I need 5 packages. I saw the bubble had room for like 1.
Great question. Oh, I love this question. So first things first, let me go into the technical side. How big of a package can this system manage? The dimensions are constrained by the size of the tube. We didn't want the biggest tube available because then where do we put it? So a 3-foot diameter tube is commonly found in storm drains throughout the streets. So it's perfect because it's easy to access and scale up. Because of that, we can basically manage a large suitcase size thing up to 30 pounds. Effectively, what we worked on is anything a human can carry without special equipment. Should be able to fit most anything. Skis, not so much. But what if you have, first, the end of that question, this technology scales up and down. So if you wanted to put us inside a 12-foot tube, we could move pallets. But inside a 3-foot tube, up to 30 pounds, large suitcase. Basically what you can carry, a cooler. The second question is escaping me now.
I was asking if you need more than one.
Oh, yes. You can send them serially. So in this bottom left, you'll see a depiction of 3 shuttles coming in. So each package gets its own dedicated shuttle. Each shuttle can navigate the tubular network on its own. So if you've got 5 things to send from here to there, you load up the first thing, a shuttle picks it up. 5 seconds later, you load the second thing. You can see that kind of in the top right. And then they just go in kind of a fleet in the network, and then they deliver, and as soon as you take off the first one, the second one presents itself in 5 seconds. Serially is the short answer, I should have said.
So I would assume that SpaceX is probably helping you all fund the initial experiment.
I can't say all the details
Right.
about it, but they did say that I could verbally say I was working with them.
Yes, okay.
But we do anticipate pilot customers to help us with
The infrastructure bill.
a setup
Right.
cost.
So
Yeah.
then what happens once you get beyond testing to another manufacturer? Have you thought through the capital raise that you're going to need in order to help, because most likely when you do a ground up a construction such as this, you're probably going to have to assume some of the costs up front. And then
Absolutely.
they'll pay on the back end. So what does your capital raise look like for something like that?
It depends entirely on the network. Some networks are going to be very short. Some are going to be large and complex with, like, say, 100 nodes. So it's very network dependent. And the short answer is, ideally, well, in the short term, it's going to be VC funded. We're going to build it, and then as we operate it, we'll get paid per delivery. Long term, we should be able to debt finance, project finance a given network. So it's infrastructure. We work with a bank to finance this sustainability network for deliveries. And then we have a 70% margin over 5 years, but the payoff, if we use all of the margin to just pay back the loan, is under a year.
So do you all own the technology, or does the manufacturing company who is putting it in place, do they own it? Because if they own it outright, then why would they want to pay you to continue to deliver per package?
Because it cuts their OpEx in half.
Okay. But they don't actually own the infrastructure at that point?
In some cases, they can own the pipe. In all cases, we would own the shuttles.
Okay, thank you.
Yep.
And
Great
that
question.
is time. Perfect timing.
Thank you.
Thank you so much, Ben. All right, our next finalist is Baron Soul, pitched by Walter Esparza.
Test, test, test. Ready when y'all are. Okay. Hello, everyone. My name is Walter, and I'm the founder of Baron Soul Tires. Every year, over 290 million tires are wasted from the U.S. alone. Only 80% of those tires are recycled. That still results in 57 million tires thrown to tire stockpiles, and they're often burned and release emissions into our atmosphere. They also result in a breeding ground for deadly carrying disease mosquitoes in developing countries. Working at Discount Tire, I wondered, is there a solution to this problem when we throw out more than 300 tires a day. Luckily, there is. That's where Bear&So comes in, a biodegradable tire solution. Unfortunately, we can't do vehicle tires because of strict highway regulation laws. Currently, there are no laws as to what kind of tires you can ride on your bicycle tire. But our future goal is vehicle tires. We do this using rawhide secretion. The same thing you saw the dog chewing on in that picture. The problem is the environment tires go through: dirt, UV, and water. That's where nanotechnology comes in. Without the coating and an incubator and bacteria, it starts eating away our bioplastic and breaking it apart. With the coating, however, not only does it protect it, it kills the bacteria. But we're going to need a lot more than just biodegradable tires to get people interested in using these bicycle tires. But how? Glow in the dark. We can make our tires glow in the dark. When often surveyed in bicycle sport shops, people are most interested in our glow in the dark tire, making it our most viable proposition. This is especially useful during the nighttime because you're statistically less likely to get hit at night if you're visible. It's also the law in most states, such as Texas. What does our average customer look like? They're under the ages of 15 or over 30. They're very active and generally male. Geographically, after COVID, in Google Trends, there's a 350% spike increase in Google Trends search for e-bikes. Europe is up and coming 11% because of their growing health environmental conscious. Our partner Morgan was able to say it for herself in Amsterdam, where they even had 3-story parking garages for just bicycles. Our competition, we'd be naive to say that we don't have any competitions. We're the first biodegradable or glow-in-the-dark tire. But it's a very aggressive market against century-old companies such as Michelin and Continental. And it's very fragmented because it is outsourced and created in China because of how much carbon it produces to produce a tire. According to Continental, one single tire requires 7 gallons of oil. Our market plan is to make contract with Austin B-Cycle, do 100 tires, so we can get data locally and fix any problems that may arise, and then start shipping out to Netherlands. And we believe we have an advantage over the tire companies because we can produce them here locally in the US as they don't break government regulation laws. And when's the last time you've seen an ad for a tire? Because they're a necessity. Product development timeline, we started with just an idea, potato starch, science projects. Eventually, we were able to perfect it. We even got nominated to compete in South by Southwest competition, but COVID happened and ruined everything. And right before I shipped out for the Navy, I was able to perfect the bioplastic. So now today, I am here again trying to get this idea up and running. And we hope to get our patent by the time we graduate college. Why us? We have the nanotechnology experience. My previous business, we would coat murals, such as the I Love You So Much mural here in Austin, protect against graffiti for life. We have a great contract with them and a great relationship as well to get at a reduced price. I have the tire industry experience, been working at tires a long time. And we have connection with scientists and mentors at St. Edward's. And we hope to get into the summer research program to get the credibility and help we need for our bioplastic. But we can't move any further without a prototype. That's what the funding is for. $1,500 to make at least 4 prototypes. And so that way we can sell it to a medium-sized company to help us get it on board. And we also need $1,250 for the lab tests. So we can test it with RE3D to make sure how well it compares to a rubber tire, regular rubber tire. This will help us get 8 months ahead. Of course, we need more than $2,500 for this, but the price for this is $2,500. But in your packets, it's a further breakdown of how much exactly we would need. I'm generally believe in this idea. I'm eager for any help or feedback as well. Please contact us if you have any questions. Thank you for your time. This was Bear&So.
Woohoo. Thank you, Walter. I feel like then COVID happened and everything got ruined is like the quote of the century. So, right, yeah. Okay, judges, 8 minutes.
Nice presentation. Thank you, Walter.
Thank you.
What is rawhide secretion?
Oh, thank you. Rawhide secretion is the same thing you saw that dog chewing on. It's keratin. You ever wonder how our skin stays together without, pulling apart into pieces when we stretch?
Every day.
Yes. That's the same chemical that's being used to make our biodegradable tire. And the rawhide is not edible. That's why it's given to dogs, and it's actually unhealthy for dogs. So it's actually unusable part of the animal. So it's been used by Native Americans for a long time as adhesive for glue. That's what rawhide secretion is.
And then my next question would be, what is the use of life of these potential tires compared to a standard tire?
That's a really good question. Regular tires last about 5 to 7 years, depending on the environment it's in and the condition. This one, I made it, 2 years ago, so fortunately we don't have data, 7 years to see how long it lasts, but so far it has lasted all the great, about 150 degrees temperature, average temperature, and even freezing cold temperature without any destruction to the rubber.
Is that just sitting in place, or is that actually moving up on gravel?
That's why we need the funding for the RE3D so we can further test it to get to that, get that data as well.
Great. And cost difference?
The cost difference, oh yes, I actually have that in here. So to produce one tire is around $8.99, and we researched or we interviewed with bicycle sport shops, and they retail margins were 40%. So we retail it for $48. So the shelf price would be $60. So we would get a gross profit margin of $39. Compared to regular tires, they are produced very cheap, but that's because they're central companies. They outsource them to facilities like in China, but they sell them really cheap. They sell them for $20, but e-bikes tires typically go for $50 to $150 currently right now. So we can make them pretty cheap.
I would just love to hear more in how you're thinking about prototyping. So you said on one slide, I think I read, you want to build 4 prototypes. Like, what are those? What are you measuring during the prototyping process? What are you trying to learn for the next step?
Okay. We're just trying to learn how to get the credibility from RE3D. They have on their website where they send you like a certificate showing exactly how well it works, and they need, I think, a minimum of just 2 to test it. But that's why we said 4 prototypes. That way we can get actual tires. It's very expensive with the cast iron molds. I'm trying to make my own with silicone, and it so far has cost me around $600. But that's why we said 4 prototypes, because every tire is a little bit different. There's mountain bikes, road bikes, and yeah.
What you have, though, is actually like a material. Have you thought of other use cases that this could go, since you said you're kind of dealing in a gnarly market?
Yes. Every time I pitch this idea, that's what people start doing. They start saying, you could do this with it, or that, or this. And for the reason I started all this was because of working with tires, so that's the reason why. But I have thought about the thing I'm trying to patent, or most importantly, is the bio rubber.
Can you speak more about the distinguishing innovation here? So you're trying to patent what aspect? The nanotechnology that hardens it or prevents it? Can you just help here?
Yep, no
Thanks.
problem. I'm trying to patent that right there. Okay. That is what hasn't been created yet,
Okay.
I would say.
And that is raw high secretion plus nanotechnology? Is that what you said?
The nano coating protects it. It's someone else already made that. It's
that?
eco-friendly.
Okay.
It protects it from UV, water, because it biodegrades without it.
Okay, thank you.
Any other questions? Do we have time for one audience question? 1 or 2? Any brave souls out there? Yes.
Here, I'll give you this.
Oh yeah, we're gonna bring the mic so that people online can hear that.
How long does it take to biodegrade? What's the life?
Without the coating, once we strip it away, it takes typically around a month without being in a compulsive environment. In a compulsive environment, it takes only about a week. It starts deteriorating immediately. It's water soluble.
Anyone else? Okay.
Testing. Hey, quick question about you mentioning in your presentation that there's about 100 bicycles that you want to sell to get enough data points. And you also mentioned something about having 4 bikes as a prototype. So can you just help us understand how you're going to go from 4 to 100, what your scaling strategy is?
Yes, as I mentioned before, there are mountain bike tires, road bike tires. There's about 4 different types of tires. This is what we're just going to be testing on, working on before we start mass producing as many as we can to get data and actual certification that this is good enough, roadworthy, before we start sending people out there riding our biodegradable tire.
Awesome. Do we have time for one more? All right, one more? Yes, right there.
Does this technology allow you to use, like, make different color tires or, like, the glow in the dark? Is that something that can't be done with regular rubber?
Unfortunately, it hasn't been done. Michelin tried to do, or Goodyear tried to do it in the 1960s, but it did not work out very well. But different colors, other tire companies are able to do that. They've been able to do that for a while now, different color patterns. But that is not our most valuable proposition. But yes, we can change the different colors as well.
Cool.
Yeah, this one's green, but without it, it comes out orange, kind of gooey looking.
Okay, and it's your lucky day. We have time for one more. Anyone else? Going once, going twice. Yep, okay.
What's your ability to adjust the tactile nature of it? I think the stickiness of the compound.
Can you repeat it again for the mic, please?
How available are y'all to adjust the stickiness of the compound?
Oh, to use it as adhesive instead?
No, just the different types of, you have rubber.
Oh, the grip.
Grip, yes, there you go. Thank
Okay, that's a really good question. That's what the testing would be for, but I can't give you an answer right now, but that's what we're going to be using the funding for, to RE3D, to test the traction as well. But I can tell you that Shore A is the same as a regular rubber tire, which is 60. But thank you. I'll get back to you on that one day.
Hey, Walter, have you thought about the carbon emission or what it takes to actually create the tire in itself? Or what your manufacturing process?
Oh, no problem. So I can tell you, first is, like I said, regular tire, 7 gallons of oil, standard tire. But this one, to make it, I have to boil it. I can use an electric one connected to a solar panel, or if I needed to. But it typically takes me about 2 hours of boiling it down. It takes a while, but it definitely doesn't use the same amount of heat temperatures as a regular tire. But if I had the number down, I would give it to you, but I don't have it right now for the exact carbon emissions number.
All right, thank you so much.
Thanks.
And then Aubrey's going to collect the judges' scores for a second. All right, and our last finalist is Paravalent Inc., pitched by Aidan Vogel, founder and CEO.
So let me ask you all a question. How many of you plan to have kids or you think you might be having grandkids? Just a show of hands. Right. So good majority. What we all got to realize is that the world that our kids grew up in will be vastly different than the one you and I have experienced. Just in 1 minute of the time that I'll be up here, 127 million pounds of carbon dioxide will enter the atmosphere. And instead of all that trash and that waste and pollution going into the environment, Paravalent is turning trash into sustainable homes. And that segues into our mission, which is to accelerate net negative construction through the values of affordability, sustainability, and in a scalable method. So why do we actually exist? As I already said, 127 million pounds of carbon dioxide or 64 million tons of CO2 enter the atmosphere a minute. Roughly, by 2100, about 83 million deaths will be due to increased temperatures of climate change. That's also around on the low side. 91% of plastic is not recycled, and the ones that are recycled are hardly used. And then fighting climate change by the turn of the century will cost about $2 trillion a year. So Paravalon's solution is to manufacture net negative sustainable homes using 3D printed trash, carbon captured concrete, cement, etc., and eco-friendly energy solutions. And personally for me, I was born to a marine biologist. I've seen the degradation of environments to a substantial level, to the point where coral reefs I've seen go from flourishing to completely bleached, just in my lifetime. And so what we gotta realize is that, as I already said, the kids that we are having will experience wild weather to the likes we have never seen, and to the point where they will only hear about, read, or see videos of the life that we take for granted. The team currently working on this over on the right-hand side is the incredibly genius Dr. Joseph Maniotis, PhD in inorganic chemistry. And then over on the left-hand side, the handsome man, if I do say so myself, background in finance, sales, and environmental sciences. And I currently have worked with Tesla with the manufacturing processes. So our go-to-market strategy is actually going to be with the materials research. And that materials research will be building a structural grade upcycled plastic filament, which we will plan to sell to our potential partners like construction companies, home builders, contractors, 3D printing companies, etc., which will then allow us to build an annual reoccurring revenue to where we will begin allowing the funding from VCs to allow us to begin producing and manufacturing these homes. So our simple customer experience is direct to consumer. First and foremost is our homes will be built from the consumer in a VR simulation that they can use without paperwork or a realtor using blockchain. And if you've ever bought a home, it's a lot of signing on mortgage paperwork that will be taken care of. My favorite part is that the homes will actually be profitably free. What does that mean? Paravalon homes will be profitable to us and free to the consumer through energy arbitrage through the eco-friendly energy. The business roadmap, phase 1 is research and development of the structural grade upcycled plastic filament. Phase 2, beginning the sales of the filament. Phase 3 is actually begin building tiny models, and then phase 4, we already have land that's granted to us where we will begin building the actual life-size prototype home. Our use of finances is mainly going to be of this $2,500 will mainly go straight to research and development of the structural grade upcycled plastic filament, which will allow us to then get to the part where you see the $65,000 a year in annual recurring revenue. And as we begin to scale to the manufacturing processes of the homes, allow us to scale to $13.9 million a year by year 4. If this is something that intrigues you and you want to begin fighting climate change in a concrete way, contact us.
Woohoo. All right, thank you so much. Judges.
Thank you very much. Appreciate that. So the basis of it then is for mostly 3D printed model homes. Is that really what we're looking at?
3D printing is just a tool.
Okay.
Just kind of think of it like baking a cake. You need an oven to bake a cake, but it's not the only tool. Yep.
Okay. Help us here.
Of course.
The filament,
Maybe.
so the idea here, we're trying to get it because there's, it's going to be a robust business as proposed. But the very first thing is you're taking plastic and waste or trash and converting that into the filament that's used to print or build.
Correct.
Is that it? Okay.
It will take the place of framing.
Okay.
Yes.
Great. Help me understand your current traction. Like, what have you been able to demonstrate to date? Are we in the idea phase, or have we been able to see or test out that conversion?
Yes. So we are in the research and development phase where we are extruding plastic right now and using additives and compatibilizers to actually make a concoction. And this is where it comes down to the key principles is how do we use plastic that is currently in our environment, like water bottles that we use every day, which isn't exactly the most strong. How do we make it so that that plastic can be used in a very scalable method? And so when it comes to the research and development and our traction so far, we already have 2 letters of partnership through 3D printing companies, and we're working to get into more contracting and construction companies to allow us to begin testing this material with one of the actual biggest problems is code, is building code. So how do we begin testing it while it's still in different variations of what is legal?
And how do you time test a product like this as opposed to something, say, like wood or steel? How do you test the strength over time when you're doing this in such a short time period?
That's an excellent question. So the cool part when it comes to plastic is it lasts for a pretty long time in different situations, right? And so we all know to a degree plastic just lasts a long time. However, one of the biggest issues when it comes to that is it going to be capable to last when it comes to heat? And so there's different additives that you put in for heat, especially for things like Texas. Plastic is good in cold, as long as it doesn't get brittle, but most plastics. When it comes to heat, though, it can make it so that it degrades quicker. And so on the sense of how long does it actually last, it's plastic. It will last hundreds of thousands, or not hundreds, hundreds to thousands of years, depending on the plastic. And so it comes down to, is it possible to make it so that it doesn't degrade due to outside temperatures? Yep.
Is that knowledge that you just shared informing then your marketing strategy?
In what way? What do you mean?
Well, if you know it's going to melt in a hot weather, would you rather sell it to construction companies farther north?
So that really comes down to the chemistry of the plastic. Different plastics are going to have different heat temperatures that they begin to melt at. And that's where you get to the additives. And so that's really the goal and where the research and development money will be spent, is making sure that these plastics will actually be structurally load-bearing in these situations of 150 degrees, because truthfully, this sounds crazy right now, that's where the world's going, to the point where we'll have 150 degrees as like a normal time. And so how do you make it so that that is capable to be done?
How are you thinking about sourcing your trash?
Thank you. That's all I can say, thank you. So there's an entire, one of the coolest part that my background of like manufacturing and environmental sciences is that there's an entire supply chain of materials right now. Lumber gets cut down, et cetera, all that stuff to build homes. Right now there's very few supply chains for this. And the amount of industries that kind of think of it as a river, need the industry that is going to actually use their material stuff is plenty of opportunity. And so that supply chain is yet to be created, but once there's opportunity, it'll happen like that.
Yeah, one of the challenges with some of that is that it's actually not clean, right? The trash is mixed and mixed use, all of that stuff. So you have to sort through and get into your concoction that becomes the filament, right? So what is the process? How do you intend to convert that trash into clean trash?
So that is not our technology. However, I know a multitude of different, when I say multitude, I know 3 companies right now that actually do that. And one in specific that's actually a startup that is completely dedicated to doing this for, there's a company called 4Ocean. You may or may not have heard of them. They are like a non-for-profit or not-profit, and they fish plastic out of the ocean. However, they make bracelets. So another good thought to this is, how do you make it so that they can have an entire huge business model scale?
All right, we have time for more. Okay, great. Any audience questions? I'll come back. I'll go to the people who haven't asked questions first.
So I'm a structural engineer, and
Thank you.
are you proposing you're gonna make like I-beams from plastic?
No. So when I say like taking the materials from different companies, there's a lot of different new green material companies that are coming out. And so conversations with different companies that will try to make net negative steel are also in the works. The plastic is just to take the place of wood. When it comes to wood, most wood is
You're
around...
gonna make 2x4s.
Correct. Most wood is only about 70 to 80 millipascals that you need, which is not that difficult to make with plastic with different additives. I-beams and more structural applications like I-beams will be used with the different companies. And that's why when it comes to the manufacturing process, our first step just for the annual reoccurring revenue is the structural plastic to take the place of wood. After that, then there's, like I said, all these companies that need that end product of the home to where we can put that application in, depending on the size of the property.
And you mentioned hot weather, but like in construction, another problem is fire.
Say that again?
Fire.
Flame retardants. That's my simple answer.
Like, have you tested it, or like it's gonna create a lot of like toxic gas?
No, we have not.
Structural stability is not the problem, but it's gonna create, because you're burning plastic.
Right.
I mean, this is just.
So there, you can put flame retardants, and at the same time, kind of like what he was talking about, is you can put. It's not the exact same nano coating, but you can put coatings on different materials to allow for flame retardants. So you could kind of put it in and also coat it.
Okay, great. We have time for one more question. Okay, right here. Yeah, you won. You won. Yeah.
What's up, man? It sounds like you could potentially have a huge opportunity at close to the beginning with your filament. Once you guys are able to figure out if you can create a structurally bearing filament from, trash, do you have any plans on using that as almost a funding opportunity for the rest of your company, like licensing this out for other companies and stuff?
Absolutely. So actually in the revenue, in the revenue, there's actually multiple opportunities. It's just our kind of, once you make something that is extremely strong, you can actually have it go down the river. And so essentially what that means is if you create a polymer that can have a very durable application, companies, educators, schools, 3D printing companies, you can use it for a numerous amount of things. It doesn't just have to be construction. It's just our focus is on construction. So a large recurring revenue.
All right, great. Thank you so much. And that concludes our pitches. Let's give a big, big, big round of applause for all of our finalists. They did an awesome job. And we are done. And before we get to the scoring, I just want to give one last huge thank you to our judges here for being here and giving up their time for us. So let's give another round of applause for them. All right, so we're going to go ahead and give you all an opportunity to cast your vote. So just go ahead and scan that QR code. And then it'll guide you, and pretty straightforward. Okay, we're going to give everyone a couple minutes to do this, and then Aubrey's going to be tallying all the scores. So we're just going to take a tiny little break. So don't leave unless you really have to use the bathroom. But don't leave. We're almost done.
Austin, that's right.
Where do you come from?
Where did I come from? I was born in a place called San Jose, California.
Do you have a mama and a dad and sister and brother?
I have a mom and a dad, but no sister, no brother. It's just me.
It's just you by yourself?
Me, and I have my wife, her name is Cassie, and then I have two little boys at home named Samuel and Oliver.
Do you have a daughter?
No, I do not. Just two boys.
two sons. Hmm? What at my house? Oh, not right now, no. Not right now.
Well, like, did your mom and dad die?
No.
Do you have a grandma?
Mm-hmm.
You have a grandpa?
Mm-hmm.
Do you have your whole family?
Mostly, yeah.
Like all your family? Don't we have to search for you have this?
I don't think I have any here.
Can we go check?
We can go in a minute. We're going to see who wins here in a second, and then we can go take a look. And then I think Mama will be done too.
But why is everybody talking?
Because they're waiting to see who wins.
What are those up there?
What?
What are those up there?
Those are lights.
And what are those white lights?
They're still lights, just a different kind.
Well, what is that? What's that circle?
That's a sign.
What kind? Can you read?
Yeah. It says Capital Factory.
Capital Factory. Where are those?
Wonder what?
Where are those? Right there.
Chairs
Chairs.
and tables, yeah.
Can I have ice cream?
I don't think so. At least not in here.
Do you guys have a fridge?
I don't know.
Okay, the moment you've been waiting for. We are ready to announce the winner. But before we do that, let's just revisit what the prize package is. So we have, in addition to a $2,500 cash prize, which is what this fancy big blow-up check will reveal. The winner will also get 3 months free rent here at Capital Factory and a 2-hour financial and HR consultation with VCFO and a 1-year corporate membership with us. All right, well, we have a special guest here by the name of Grace who will help our City of Austin, Jackie Mayo. So Grace, so you see this check? It has a name that's very important. So when I say 1, 2, 3, you're going to help Miss Jackie here turn it around, okay?
Yeah.
Okay? All right, I tried this last time at the pitch and it worked really well. Can I get a drum roll, please? There we go. And the winner of the Austin Fast Start Cleantech Pitch Competition is, turn it around. Tubular Network. Woo! Okay, Tubular Network, come on up. Yes. This is your Oscar moment. You can, yes.
Do I say things?
Yeah.
Oh my goodness.
Thanks. Yeah.
All right. Well, first and foremost, I'd like to thank my competitors for their awesome pitches. It was really inspiring. It's one of the first pitches I've done in front of a crowd. I've got great colleagues in competition up here, so thank you guys. To the judges, thank you for your time, your wonderful questions, and of course, to the star of the show, thank you, Miss Grace.
Congratulations.
Congratulations. Thank you so much. Yeah. Want to give him this check? Okay, we're going to take a quick picture, quick group picture.
Can I get the tubular team?
Yeah, of course. Come on up.
Dylan, quit nerding out over there. Should we move over this way? Okay.
I'm just gonna keep taking a bunch. 1, 2, 3, smile.
All right, thank you, Grace. Thank you, Jackie. All right, well, that concludes everything. Thank you all so much for coming. We did want, do we have a slide on? Okay, all right. Well, as you all know, we have tons of events. So if you enjoyed this, if you're new to the Austin Young Chamber and you're looking for ways to get involved in the community and meet other young professionals, please, 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 we cannot emphasize enough, this is a great place to do that. So that QR code is for our newsletter, and we send it out every Monday, and it has all of our events and other community resources. So if you are a small business owner, you're looking for a job, you are looking to just have fun, this is the newsletter for you. So anyway, thank you all so much. That's it.
He's in everything.